Madam, shall we start?
We can.
Hello?
Yes, ma'am, we can start. Shall I?
We can start. Ha, wait. Okay. Good evening, everyone. Good evening, madam, and good evening, sir. I welcome to this 6-day online FDP, ATAL FDP, and thank you all the participants for joining the workshop and contributing in success of this program. Actively participating from 4 days. It is today is your fifth day. So it is my great pleasure to introduce our distinguished resource person of today's session, Dr. Chitrakala Madam. Actually, this is the coincidence we can say today is our Teachers' Day. So I would like to wish each and every one over here Happy Teachers' Day. And we are very much proudly I can say that our HK Society PD College of Engineering foundation stone was led by Dr. Sarvapalli Radhakrishnan sir himself. So we are very much blessed to see that, and it's our great pleasure, madam, to having you here. So, madam is professor in Department of Computer Science and Engineering, College of Engineering, Anna University, Chennai. Dr. Chitrakala Madam has an exception 30 years of teaching and research experience. She currently serves as the Director of Center for Immersive Technology CIT and Professor in charge of AICAU Incubation Foundation, Anna University. Madam received her BE and ME from the University of Madras and her PhD in image mining from Anna University. Her major research areas include data mining, computer vision, artificial intelligence, machine learning, big data analytics, augmented and virtual reality, web information retrieval, and natural language processing. Her academic contributions are remarkable. Madam has published more than 160 papers, guided 11 PhD scholars, and currently guiding 6 more, and holds one granted Indian patent and 3 published patents. She has been the principal investigator for ISRO and CMRG funded projects and also served as principal consultant for AI consultancy projects. Dr. Chitrakala Madam has been recognized with several honors, including the Dr. Sarvapalli Radhakrishnan Distinguished Professor and Researcher Award, 2022, Best Teacher Award 2018, Women Researcher Award 2018, and Bharat Vikas Award 2017. She also received NVIDIA GPU Grant 2018. She has played a key role as University Coordinator and Technical Committee member for the ATAL Incubation Center at Anna University, funded with rupees 10 crores by Niti Aayog, and she is the nodal officer for the centralized data management center funded with rupees 30 lakhs by the Tamil Nadu CM fund. She has organized more than 20 short-term programs and conferences and has delivered more than 80 plus guest lectures in various reputed universities and institutions. She is also an active reviewer for reputed international journals, has served on program committee of premier conferences, and is a professional member of ACM and life member of IST and CSI. Today, Dr. Chitrakala Madam will be delivering the session 9 from 6 to 7:30 p.m. on the topic Advancing Visual and Textual Experiences by Combining AI and Augmented Reality. So we are honored to have such a highly accomplished academician and innovator with us in this evening. We welcome you, ma'am, for this workshop. And I also welcome our principal, Dr. Sidra Mar Patil, vice principals, Dr. S.R. Hotti sir, and Bharti Harsur madam, and all the HODs and deans and faculty, staff members of PDA College of Engineering, and all my dear participants. Welcome to this fifth day of the workshop. I welcome you, ma'am, and over to you, madam.
For introducing me. First of all, I would like to thank Professor Jayashree madam for having me here for one of this nice session. And of course, I thank Dr. Professor Siddharama sir for giving me this opportunity. Let me share the screen. Slide visible?
Yes.
Okay, thank you. So today's session is advancing visual and textual experiences by combining AI and AR. So before that, I would like to give happy Teachers' Days to all teachers who are here. I know that it is a very heterogeneous crowd from
Thank you, ma'am.
various disciplines. But anyway, many are teachers here. So happy Teachers' Days to all.
Thank you, ma'am.
Today's session is on convergence of AI and AR to have a better experiences with respect to visual and textual. So this is the agenda for today. So I'll slightly one or two slides, I'll talk about basics of AI and connecting with the topic. And we'll move on to the basics of AR, VR and MR, mixed reality also. Then I will introduce various technologies behind the screen for AR, various types of AR, and we'll try to have an understanding how AI is contributing a lot to this AR field. And there are very many applications and use cases I will share, followed by successful case studies or success stories for AR AI combination. And I will introduce a lot of tools so that it will be useful for you later to proceed with this slide. And I'll be ending the closing the session with future trends. So first, let us, because the title goes with the combination of AI, AR. Of course, we are all very familiar with this AI because we are living in an era where even the layman is in knowing this term. Actually, recent days it is becoming more buzzword, especially generative AI because of the invent of this chat GPT. And we all know that the artificial intelligence is nothing but this is a way by which we are enabling the computers to think and learn like humans, right? You know, always, you know, the mimicking the human being is a great, great challenge. So in all ways, right? In all manners, in all aspects. So here, this AI is nothing but the ability of the computer or machine to perform the task equally like human. Even sometimes it will supersede humans also. So it will try to mimic the human intelligence, such as learning, problem solving, decision making, and things. So here, to perform all this capability, right, to have this possess this capability, it has to understand the natural language. It has to recognize the patterns, right, and it has to solve the problems and making decisions. So to make all these things possible, one second. Actually, we have these are the subdomains under AI, as you all know: machine learning, neural network approach, natural language processing, and robotics. So, if you are expecting the system to recognize the patterns, right, that is possible with the help of training, learning, making the system to learn. So that we call it as machine learning. And of course, the neural networks will help the system, AI system, to imitate the neurons in our brain to mimic the human being's intelligence. And of course, NLP is the ability with which it can understand speech or text, whatever the way in which we interact with the system. It will first try to interpret or understand and start analyzing the documents. And of course, there are very many places, even though we have AI solution, there are some manual interventions will be there. But even without any manual intervention, you want it to be fully automated. There comes the robotics. So here, the machines can assist the people without actual human involvement. So the ultimate goal is to have the human intelligence, right? Whatever the capabilities we possess, the learning, how we learn, how we solve the problem, we are expecting the AI things, AI algorithms to do the same. And in recent days, you're all familiar with generative AI, because why I'm talking about this generative AI here is that it will have a lot of scope when I connect with AR, augmented reality. So here, as we all know, it is a subfield of subfield of AI, and here it is focuses on generating the new content. That's why this word generative AI. So here, for example, whenever I say generating the content, not only one modality, anything, especially if you want to generate and synthesize the new text, or you want to synthesize, create a new images, audio, music, video, even code, right? Or 3D objects or any synthetic data. If you want it to be automatically generated, synthesized, we go for generative AI. And of course, it uses a deep learning model, as we all know. So when you see that, one second, deep learning model, we'll pick, yeah, when we say deep learning model, of course, that will be trained on large amounts of data. And of course, it can perform multiple tasks, right? As we do, human beings do. So when you see the capabilities of this generative models, AI models, it will generate images like this. Suppose you give the input and this is a ground truth you want it to be. It will generate or create image like this, having given the input like this, right? So this is for image. Even for, it will generate a speech, right? On its own, it can generate handwriting. It can generate the conversation on its own. We call it as conversational AI assistant or AI agents or chatbot, right? So these are the some possible capabilities of generative AI. And if you see the use cases of generative AI, as I said, the content can be created. The content can be in the form of any modality, like it can be text content or image, or even it can be 3D assets, uh, which is to be used in your AR, VR, like that. And even the image generation, video creation, right? Even music generation, code generation, even the idea generation, as we all know, these are all the capabilities of generative AI. And even it is used for the predictive analysis, data, normal data analytics, risk management, fraud detection. So there are some few use cases mentioned here. Of course, there are a lot many. The things are possible with the generative AI. So having got to know the very basic definition of AI and generative AI, let us get on to the main topics. AR, VR, MR. Then I will connect AI with AR. So as we all know, the word itself gives the meaning. This is augmented reality. That means that here there's a technology which will add the digital elements to the real world. Otherwise, we can say it will augment the real scenario with some extra digital. So the enhancement of the real world will happening in what way? What are the things will be can be added is that sensory elements can be added to it. For example, the text can be overlaid, right? It can be added as a digital element, or even the sound can be added, even the image can be added. So all those things, digitized elements, objects can be added to the real world objects. So that's why this is called augmented reality. So we call it as here, it is overlaying, right? So it will overlay the sensory information in addition on top of the real world, whatever you have in front of you, so that your experience will be more enhanced, right? So that is the purpose. Anyway, in due course we'll see a lot of examples, right? So the here we can say that it is a combination of real world and the virtual world, right? See here, she is wearing a glass, so in front of that the real world, she has some physical object, right? It is viewed by the user. On top of that, the virtual scene has been generated. It has been generated by the computer. Of course, it is being augmenting. It is augmenting the real world. And if you see at the right top, so suppose we have developed one AR app, which is loaded into your mobile, which has the camera, right? And through which we are visualizing, we are seeing this on top of, if you are keeping your mobile phone with the AR app installed to see something, right? It will, on top of it, it will overlay the information. It's not mere overlay. It will capture the image in front of it. It analyzes the AR algorithm, right? And then it will overlay appropriate information. Here, for example, what is this? Is it an office building? This is a shopping center. This is an apartment building. Something like this. It does the image processing, right? It takes care of all computer vision algorithms. It's just being applied behind the screen and it will overlay the information. So the overlay need not be only text, right? Here, the overlaying can be anything, even the image or even sound also can be augmented. That we'll see it later slides. So it is a type of technology that will allow the digital images and information to be displayed over the physical environment. So that's why the reality is being supplemented, augmented with the digital elements. And if you see here, the person standing before, right, he's simply pointing a camera at the sign, and immediately he see the translation on the screen, right? So this is the in front of the reality, real objects. On top of that, immediate conversion, the translation is happening from one language to the other. And one more thing, here the operations will be based on the location and orientation of the user as well as the device. For example, here, if you point out this place, right, at the real time on the fly, it will capture this image of the particular equipment. It will analyze the health of the equipment, and it will say that some leak is there, right? Some problem with this place or some device. So the health monitoring and correcting or predictive measures also can be done. So the analytics will be happening behind the screen, but it will provide the results, right, in the form of this analytics on the over the image, over the physical object. And if you see the virtual reality, the word itself gives a meaning. It is virtual, right? So here it will create a new and different virtual world in front of you. It will give you the more immersive experience. So it is a simulated environment, but it's completely entirely different from the real world, right? So here, of course, you are supposed to have the VR glasses to see this virtual world in front of you. And we can use a HMD, head mounted display, through which only we can see the virtual world in front of us. And the same thing is represented here. It is a technology that will allow the users to immerse themselves in an artificial computer generated environment. And of course, we can also interact with it in real time. I'll show all those interaction later slides. And if you see this one here, a person sitting in front of the display device. And here, this is a demo setup with VR head mounted display. Steering wheel alone is there, but the person is feeling that he's sitting in a car and he's driving. So it is a kind of training simulator. So wherein he is able to get trained how to drive the car. Okay. So it will, it's not simple like a computer monitor and in front of which you see the animated video or already recorded video. It is like a real place where you are inside the car. You can feel so, right? So it's possible with the help of computer vision and of course, advanced graphics mechanism that we will see it in the later slides, how it is possible. And one more term is MR, that is mixed reality. Again, it is mixed. So the combo, right? Combination of this AR and VR. So it combines the elements of both AR and VR. That nothing but overlaying the digital objects, of course, onto the real world in the flavor of AR. Also allowing the interaction with the virtual. For example, in front of you, the virtual elements have been digital objects have been created, and you are able to interact with the virtual object. So you have physical world in front of you in addition to the virtual world, and virtual world you can interact also. So that's why it's called mixed reality. So here it will merge the virtual reality and real world together, right? But of course, the digital object and physical object will coexist together, right? So we'll be able to interact with each other. So it is not like you are living in virtual world or like you are living in a real world. So you are somewhere in between. So that's why it is called as mixed reality. So having got to know what is AR, MR, VR, if you see the this thing, no, the spectrum. So this we call it as Milgram's reality virtuality continuum. So the leftmost side you have real environment, the rightmost end is a virtual environment, right? The end-to-end spectrum is mixed reality. So that means that here, the left side, if you come from the real world, it is being augmented. We call it as augmented reality. So on top of the real world, the digital world, no, objects have been overlaid. But otherwise, no, the right side, the virtual environment has been created with VR. On top of that, also the augmentation is possible. So that we call it as augmented virtuality, right? So here, which are most synthetic, right? Some real world imaginary will be added, right, onto the virtual object like this. So end to end, we call it as MR. And there are some more terms I want you to have an idea, like that just now I introduced VR, like it's completely computer generated environment in front of you. It's nowhere, it's not a real world, it's an entirely virtual world. If it is augmented reality, you have in front of you real life as well as on, in addition to that, it is adding the virtual object, right? Diminished reality in the sense, you in front of you have an environment, but this system will alter the real object, replaces with the virtual one. The real one will be replaced with virtual one, and it is rendered. So that is called diminished reality. And we have mediated reality. So combination of AR and diminished reality. And one more thing is collaborative. I think you might have heard about metaverse, right? So it is an environment where people from different geographical location will be available there as in by their own avatars. They'll be able to interact with each other. They can collaborate and they can interact. They're able to manipulate the virtual objects also. For example, you just imagine we have the virtual classroom. So the students from various geographical location, we are getting connected, right? And we are sitting in the class. So there, the virtual classroom will be there. My avatar, I'll feel that I'm inside the classroom. I'm sitting in one place next to me. I can see the other person sitting, but that is he is not really present physically, but he is from some other place connected to the system. And we all together can listen to a class. We can interact, then we can visit our library, virtual library inside our college, something like that, right? It is a collaborative reality. Everything is virtual, but it's collaboratively, the interaction is possible with respect to each and everyone. But over a large distance, we are getting connected, right? Because during COVID time, we all got connected, right, in through online mode classroom teaching. So there, it's only the online platform. We are physically sitting here and we are able to listen to the others. But the real immersive environment were also not there, right? But in this collaborative reality or metaverse, that is possible. So whatever we are telling, no, that we come to know about AR, VR, MR, it seems like a magic, right? What are the things making it possible? So the components of AR, if you could observe, it's a hardware components. Of course, you have to have sensors and displays. With respect to the sensor, of course, camera sensor also is there, even touching the tactile gloves, something and all. And software components with respect to that, we have to have software for tracking and rendering the environment, virtual environment. And the types of augmented reality, if you see, because I have introduced AR, MR, VR, MR, I mean mixed reality, and now we got into AR. The title goes like this: convergence of AI with AR, right? So now we got into starting with AR. So with respect to augmented reality, the types are marker-based AR, markerless. The markerless is otherwise called location-based and SLAM, right? I will introduce this term later. And then projection based AR, superimposition based AR. I will introduce one by one. So if you see the system components, these are the ones, right? So we have to have a processing elements and display devices, right? And sensors for tracking and your input devices. So, and you have to have the headset, something, sometime, no, even without the AR kit also, AR headset also, you can visualize the thing in the monitor, the display of your normal mobile, or even it can be web AR also. So let us try to understand how this AR works, right? The working principle. So it's ultimately we understand that AR is nothing but it's overlaying the digital content on top of the real, right? So for example, if you see this diagram, right, here it's a marker, right? Suppose if you have markers, for example, QR code, something like that. So you can simply keep your whatever the device, whether it is a mobile or some device you have developed for AR. If you focus on this marker, right, immediately the whatever the sensor at your device, if it is a camera, that will capture the environment in real time. It will recognize the objects and surfaces in front of it, right, with the help of obviously the feature detection mechanism, depth mapping, everything with respect to which it will identify the distance between the objects, everything. And then it identifies that there is a real object in front of that. On top of it, it is overlaying this virtual object. See this? Some kind of ball. It is being virtually created and it is being positioned or anchored over the marker. So that's why it is called as marker based, right? Some marker will be there. We have to just focus on the marker so that the digital elements will be rendered, right, on top of that particular marker. And whenever it is being rendered, the alignment is very much required. So it has to get aligned with the physical surroundings. And it is possible with the help of all these things: hardware, software, sensors, computer vision mechanism, right? And as we all know, the sensors are nothing but here, of course, camera through which the environment has been captured, the objects are recognized. And this is for markerless, of course, I'll introduce the mechanism later, wherein the GPS accelerators are very much required for tracking the user's movement and orientation, user's location and orientation of the device, so that accordingly the overlaying will happen on the device. And of course, computer vision, without which we cannot think of AR. And the projection, of course, it will display the content on whatever the device you have, right? If you have the device on the screen, it will be displayed, or you can make it to happen on even on the wall also. That is called projection based. That we'll discuss later. And of course, processing algorithm for positioning the digital content and display is required. So those things are given in detail here. So these are the technical components. Hardware wise, if you see, of course, you have to have the device with the camera or sensor, either in the form of either you can have smartphone, even tabs, which has the built-in camera and all those sensors, right? And you can wear the smart glasses also, right? HoloLens, through which if you see, you can see the overlaying of the digital content. And of course, we have HMD, head-mounted display. So that is for VR with AR capabilities. And if you see the software, we have SDKs and apps, right? Toolkits like AR Kit and AR Core. AR Kit is for Apple, AR Core by Google. So they have come up with these two tools. And Euphoria is another tool to develop the AR applications. And there are very many specific AR apps are available, retail, education, and gaming scenario. And with respect to sensors, of course, whenever I say you keep the device on the marker, it will do all wonders. How? In the sense, through the camera only, it will capture the real world images or surroundings, right? It will try to understand and it will overlay the digital content. And even the GPS, whatever the device you have, it should have the accelerometer, gyroscope, or GPS, through which it will get to have the location data, where exactly the digital content needs to be overlaid, right? And in the marker list, actually, we don't have marker in front of us. Only the user location is to be spotted, and what is the angle by which he uses a device that should be tracked. So for that, accelerometers, gyroscopes will be used. And of course, we have to have processing unit. If it is mobile processor, of course, if it is smartphone or tabs, the built-in processors will be used. And sometimes, we have dedicated AR chips. Specialized chips are also used because for a very complex processing is required. It cannot disturb the normal processor there in our mobile phones. So the specialized chips in some devices to get to have the optimized AR performance are also possible. And of course, display technology, as I said. So screens, appropriate display is required, right? So either the smartphone monitor or display or tab can be used to display the AR content. Or we can have the smart glasses, right? So that we can wear through which we can see the overlay. Or we can have the projection system, projector, that will project the images on any surface, right? Without personal screens. And if you see the types of AR, as I earlier mentioned, we have marker-based AR, markerless AR, projection-based AR, and superimposition-based AR. I'll introduce one by one. Have a look. This is marker-based AR. So here you could see everything here. Either you can use a mobile phone, smartphone, or tabs, which has a built-in camera and sensor so that it is easy to capture the environment or surroundings. Here it uses the physical markers. For example, either QR code or in front of us some images are there. You just keep your device on top of that, the marker, right? Immediately the AR device will recognize this marker and appropriate analytics will happen on the AR app, whatever you have inside the system, inside your device. Then it will do all necessary thing and then it will display the digital information. For example, see here, there is a QR code, that's it. If you keep your mobile phone on top of that, immediately it will trigger the AR app here because the marker has been sensed, right? Then it will it will overlay some chair over on that, right? So it is creating something new on top of this QR code. So this is a digital object has been created and it is displayed. Like that, if here it is the Eiffel Tower, something like that. If you just keep your device, AR device, here it's a tab. If you keep on this, it is treated as a marker, image has been sensed. Then here, for example, any tourist wants to know what is all about this, right? Instead of visiting the museum. So immediately it can be displayed in the form of an image, detailed image, or sometimes even the video also can be played back. describing about what is all about this place and the historical views about it, right? All information can be shown on top of this. So it is augmenting the reality. So the real is this. On top of this, it is augment. For example, here, some marker is there, marker image. It is sensed and it is creating a house on top of this. So everywhere it is like this. See here, here it is only, it is written like it was raining there. Only that word is there. So if you keep on top of this, so the cloud and raining is created synthetically, artificially. So it is marker. And markerless. Markerless is otherwise called location based. That means that we don't have any marker in front of us. But only here, uh, so here, before see this one, simply we focus on this place. In front of us, we don't have anything, but it is augmenting with the information how this place will look like this, right? So that is a kind of markerless AR. And if you see this scenario, in front of this image, if you show that, it will identify this as coffee shop, this is a shopping mall, something like that. And if you turn your device like this, it will understand the orientation of the device. Accordingly, it will render the overlaying information, right? Display. And suppose on this, if she focuses like this, it will understand the location of the user because it is not treated as a marker, right? It is a markerless. So immediately it will generate the overlay content here. And projection based in the sense here it is projecting light onto the real world. So it is like an illusion, right? It will create an illusion of depth and so you can even alter the appearance of that physical object in front of you. It is a projection in front of you like this. And superimposition in the sense, for example, it is a already some deteriorated building, right? If you focus your AR device on this, immediately it is reconstructing, right? See, it should be like this, but it is already deteriorated like this. So it will reconstruct the remaining portion. It will replace the original view with an augmented view, right? It sometimes is replacing entirely with a new. For example, here, the children are here, in front of them, it is only 2D image, but here it's tactile display is provided. Tactile in the sense they can touch and feel the 3D view. So it is only 3D view has been generated of the particular place. For example, here the in front of us something is there, and if you focus on that, superimposition, it will reconstruct how it should be, what it should be, right? Even here, the machinery, right? So if you focus on that, it will give the entire one, it will replace with the actual machinery and it will tell us what is all about. So it is a superimposition, replacing the original view with the augmented. That augmented one can be for a different purpose. So the major category, as I have mentioned, it is marker based or markerless. In markerless only, we have location based, projection based, overlay AR. Overlay AR, I will discuss in the next few slides. And contour based also, I will discuss in the next slide. So far, we have discussed location based, projection based. Now we'll see the other mechanisms. And this is one comparative things between marker based, markerless, projection based, superimposition. Outlining is otherwise called as contour based or edge based. And you could see that the purpose where it can be used, marker based, especially museum exhibits. So here it is like a virtual try on technology, right? So in retail and all, you can use it like how we will look like if you wear this dress, something like that, right? For the commercial applications. Even markerless is like uh, as I said, the Pokemon video games, right? In front of you, nothing will be there, but if you focus, immediately it will generate the Pokemon character, animated character. It will add on top of it. So something like that. So the projection just now I have covered, right? So it's a projection of computer generated information onto this fossil, right? Children are experiencing. And superimposition is that it will generate a new view. It will replace the already available. The outlining is the one that I will cover in the next slide that is called as contour based. There are some applications where we particular about the edges. For example, if anatomy of the in medical field, the doctors are teaching the medical students anatomy. So if they want to have an understanding about it, Sometimes the edges of the particular object is to be traced properly, right? To know what it's all about. Then on top of it, it will overlay. So that is called as contour based. I will cover it in the next slide. So with respect to the overlay type, right? In AR overlay, there are many possible ways of overlay. As I said earlier, the overlaying information, right? The augmented digital information can be either text to overlay, can be image, even can be 3D models, can be video, can be sound. So if you see the text overlay, so here you could observe that there's a marker in front of you. Simply I'm focusing this device on top of this. So the immediately it is capturing the Chinese letter or word in front, some letter word. It is converting into translating this into another language, right? Immediately it is flashed back in English. So here the textual information is overlaid here. And this is Google Translate AR mode, right? It's simply you point out at a document, immediately so you could see the translated document out in the form of text. And even it is used for heads up display in cars. So when you drive the car, you want to know some driving information or navigation instruction in front of you, in front of the windshield, then it is possible in form the terms of text. And then other one is image overlay. That means that in front of you something in real, but you want to get some augmented information about it, about something. So image, for example, this is a scenario. See this, some place, seashore, something like that. So if you keep your mobile phone here, you could observe that here it's only cloudy, not here. So that means that it's a AR weather app, right? It's simply predicting the weather condition. It may going to rain. So the clouds, it is generating as overlay information, image on the current sky when you view through it through this screen, right? So you could understand that it has a predictive analytics, AI analytics. But if you see through it, it is showing that within some time it is going to rain. So it is the AR weather app. And even IKEA, I think you all know the IKEA furniture shops and all, they have that apps. So simply you can use that AR app. You can visualize before in hand, if you purchase this furniture, how it will suit for this place, how it will look like, that you can experience before you buy. Try before you buy. And the other one is even the 3D models can be overlaid as a digital information on the reality. For example, Google AR search, right? So simply, if you show in front of something, it will generate a 3D object, right? In the form of, for example, you could see some animal, right? The cheetah or a tiger. It is projected on this place. So that you can have the 3D view. Even the Pokemon characters too can be overlaid on top of any gaming environment. So there, the 3D models can be overlaid. And video overlays, right? Even not only text to image or 3D models, even we can have the video. For example, see here in front of us, some only the flight, the image is there. On top of it, if you show this, it will give the information about that video, I mean, flight in the form of a video. You can have the playing of video content as a overlay. Okay. Even advertisements and all. So you can have the static image on top of it. If you show, you can find the engaging video, right? And even interactive museum exhibits. So an exhibit, if you go and show it on top of it, it will play back something about that. And in addition to the image or video, of course, you can have the sound overlay also, right? For example, here, these are the fossils, something are there. She's pointing that one with the device. Immediately could see that some images popped out, played as a video, along with synchronized audios, audio guides, right? Even AR museums and all, we can have the audio guides. And of course, navigation. So when you go through the city and if you want to have information about what it is, everything, so you can nicely focus on top of the street. It will show you the navigation direction along with audio overlay. And haptic, you can also touch and feel, right? For example, in terms of vibration, suppose some digital virtual element has been created and it is augmented with the reality right now in front of you. You could see, no? In the playing hall, if I focus like this, I could see the sofa. chair, something like that. In addition to that, you can also touch haptic, right? You can provide some vibration, some pressure sensation you can find out. Even you can feel the texture. When you're touching the virtual object, you can feel the textures, right? For example, if you're doing a shopping experience, I think all be very familiar with the Lenskart and all. They have AR app. Without wearing the glasses, if you show your face in front of the camera of your phone, it will you can choose the it will make you to wear a different specs. You can feel how I look like if I wear this specs or that. That is for visual. In addition to that, you can also touch and feel the textures of the cloth, something like that, right? Shopping experience. So these are all text to visual, image, audio, video, haptic. In addition to that, contextual information can also be overlaid. For example, it's a Google Lens, for example. When you point your camera at the landmark, simply will say something about what is this place, what is the history of this place, what time this shop will open, right? Opening hours and reviews, everything will be popped out. So it's something about the contextual information, right? So even for navigation apps also, you will come to know the overlay will show the arrows and whatever the place you are, where you want to go, how much distance is there. So something like that, it will tell you contextual information. And I already told you about outlining AR, that is otherwise called contour based AR. As I earlier mentioned, sometimes recognizing the contours and shape of the real world object will also be useful to place your virtual content, right? For example, as I earlier said, some architectural design is there, right? Construction, I mean, one architectural design. On top of that, we want to have the overlay. First, it has to sense the edges. For example, if you have some anatomical view of our body and it has to sense the edges contours, then on top of it, it can provide the digital overlay. So that's why it is applications mentioned as architecture and design, education, gaming, medical training, those places. So the contour is detected and then overlay is done on top of the real. What is the technology behind AR, right? So just now, because we have the connect of AI with AR. So what are the technologies in that? What is the importance of AI will come to. So computer vision is one major thing without which we cannot think of AI. Of course, computer vision also as a one component of AI, right? So if you see the image recognition, of course, image recognition is a very crucial part in AI. It has to identify the markers, right? QR code or whatever image, and it has to trigger the AR content accordingly. So image recognition is important one, and depth mapping, right? Once recognize the images, then it has to identify the objects, then it has to determine the distance among that, so that the digital content can be properly anchored, right? And marker detection, object recognition everywhere. And SLAM is a technique that is called simultaneous localization and mapping. In markerless AR, I said that I don't have anything in front of me. I don't have a marker. I need not show my device pointing to the marker. Instead, I can show anywhere, something like that. But it has to identify what is the environment in front of me, and it has to track the device position. So whatever the angle at which I keep my device, accordingly, it will anchor the display content. At the same time, it has to understand the environment also. So mapping the environment while tracking the device. That's why it is called simultaneous localization and mapping, right? So it will allow the device to map an unknown environment as and when keeping track of the location. So that it will create a map of the environment based on the sensory input. So in front of me, whatever is there that will be recognized, localized. At the same time, it should be mapped to my device location. Then digital information can be overlaid. So here one word is there based on sensory input. Based on the sensory input only, we have different types of SLAM. Visual SLAM, LIDAR SLAM, RGB SLAM. If it is visual SLAM, of course, when I point out here, I use the camera, right, to extract the visual features so that it is used for mapping and localization. If I use LiDAR, of course, it will make use of laser scanning to create the 3D maps. If it is RGBD, it combines both RGB information with the depth data so that it will try to understand the environment better. And of course, tracking and mapping, just now I said, right? If it is marker based, it has to understand the environment and it has to anchor the digital content. For that, it has to track and map. Markerless also, it has to depend on GPS and accelerometer and gyroscope just to know if I keep on move, the user position has to be tracked. And whatever the angle by which I keep my device, the orientation is also to be tracked, right? Because it's location based AR. And SLAM just now I explained. And of course, display technology, as I earlier said, in front of you, you want to see the digital environment, right? On top of the real. So either you can make use of the display from the camera, display from the smartphone or tab, or through smart glasses you can view, or you make use of projection system. And as I earlier mentioned, of course, another technology is used as SDKs, right? Software development kits. For iOS devices, no, the Apple has come up with ARKit. And for Android devices developers, Google has come up with AR Core. So ARKit, right? So these are the tools for developing, right? Understanding environmental stuff. And Euphoria, I think you might have heard about Euphoria, just to develop a AR platform, both marker based and markerless. It will do. And of course, the main thing is that the digital content development, it requires 3D modeling and of course animation. So 3D graphics software, right? Blender, Maya, Unity, they are required to create your 3D models and to incorporate animation so that it can be rendered also. And of course, the game engines to make it as animated mode. Unity and Unreal engines are the popular choices. And rendering, we have game engines and real-time rendering is also possible. And one more thing is that content creation tools. Just now I said Blender, Maya, all those things. So suppose if whatever the sector for which I develop my AR solution, accordingly the 3D models to be developed. So this is called as the content creation. For example, if I develop AR for medical domain, if I develop for education domain, the relevant digital assets are to be created, right? For that only the Blender and Maya are used. And one more thing is, as usual, any solution you develop, cloud services and networking, right, for storage and processing to have the better AR experiences. They are required. Of course, UI, user interaction, user interface. And one more thing is interaction. See, always I said that you can give the command to the system for interaction. Voice has to be given, or a text can be given to interact with the system, or even touch, even gesture. If I wave my hand like this, if I do some gesture, the system should understand accordingly. It should interact with the virtual model. Simply after the virtual model is created, if my moving like this left side, the device has to move this way. And if I say right side, it has to move this way. Like that also I can make it. So the interaction, manipulation of the virtual objects may be based on my gesture also. And then of course AI, right? The machine learning without which we cannot think of object recognition detection for any intelligent AR solutions. Because the main thing is that it has to understand the environment. It has to, recognize the objects in front of it. That is possible with the help of computer vision. Of course, it requires machine learning to learn the things, right? And of course, NLP, whenever you speak to the system for interaction, that is possible with the NLP. And general AR development steps, just for the sake of high-level understanding you have given. Of course, you have to first define the goal for which sector, for what is the purpose for my AR app, right? I have to decide who are the target audience, and you have to analyze the market, get to have the technical requirement, and you have to choose the tool accordingly. So either if it is what device it is going to be rendered, right? Either iOS devices or Android, I have to choose accordingly ARKit or AR Core. And I have to development environment, I have to choose like Unity 3D, something like that. Then I have to have the UX, right? User interface. And the 3D assets creation is very, very important. So whichever sector for which you are developing, accordingly how to develop the 3D model and animate. Blender and Maya, right? And then you implement the features and integrate with the 3D model. And as usual, testing, optimization, deployment, post-launch. These are all required for the normal any solutions. And now, so far we understood all basics of AR, different types of AR, and then how it can, what are the technology behind that, what are the components required. Now let us try to understand the impact of AI on VR and AR. So the first one, AI ability to analyze and process a big data. In that way, AI is in, right? And NLP, as I said, for interactions. Of course, computer vision for object recognition and realistic physics simulation, right? So whichever either person you are mimicking as a virtual or you are mimicking any object, the entire physics of the particular object should be simulated. And intelligent avatars and character creation, there also AI role is there. So in what way it will contribute? It will provide personalization, adaptive learning, right? Real-time guidance and support through generative AI, and of course, enhancement, accessibility and inclusivity, right? With the help of machine learning. So I'll show a lot of examples now. And with respect to AI, the understanding is AI is a very broad umbrella term. You all know that. Under that only we have ML, GL, and the modality on which we work on, based on which we have computer vision mechanisms and the natural language processing, everything. So all those things are here anyway needed to realize all AR applications, right? So as I earlier mentioned, computer vision is a very, very important one, which is empowering AR devices because a device has to see the environment and understand. For that, machine learning is very much required, as I earlier mentioned. So it has to understand the user behavior pattern, right? So it should get learned, it should get trained. All those things are there. And it has to recommend accordingly. Some analytics should happen at the behind the screen, right? And it should display back the required one in the required digital information. Sometimes, it can even be recommendation also. And the user behavior analysis is also is to be required behind the screen. Personalized solution is expected to be delivered. If I use the system, I need some content. If other person is using accordingly, system has to understand the end user and it has to provide the content accordingly. Provide the content in the sense overlaying content. So the user behavior analysis is also required. And general data analysis comes under AI component. And as I earlier said, the spatial mapping, right? Understanding the physical space in front of the device and mapping it. Of course, with the SLAM mechanism, as I just now covered, simultaneous localization and mapping. With the help of which only wherever you are standing, whichever direction you keep your device, you are able to enjoy the overlaying information coming up on top of the real signal. And again, the same thing is reiterated. Object recognition tracking is one area where AI has a role to play with respect to computer vision and SLAM. And of course, NLP, the way in which it is understanding your voice commands and text recognition. For example, in front of you, text is there. You keep your AR app on top of it. So it has to recognize the text. So OCR, help, everything is required. And gesture recognition. And if you wave your hand or body tracking has to be interpreted. Sometimes, even your facial expressions, it will be captured based on the emotion you are. It will provide the AR experiences in turn. And environment understanding, as I earlier said. And with respect to personalization, based on gesture or whatever it is, it will provide the adaptive content. So as I said, based on the behavior of the user and context, it has to adjust the AR content, overlaying content, right? It has to tailor, tweak. So that's called adaptive. And of course, context aware. So the personalized content, based on the context, it has to be provided. All these are AI components. And whenever I say real-time data processing, of course, we want to have very, very immediate response, The AR experience should not be delayed much. So low latency is very much required. So edge computing will be used. And sometimes, there are very many sensor data will be, acquired, and it requires a data fusion also. So because we need the real-time response, it should be very fast enough. So it has to take care of all this parameter. And content generation, already AI-driven animation are available. So you can have the virtual characters animated in real time. For example, in any gaming scenario, whatever the way I play, accordingly the characters will be generated dynamically in front of me, real time, right? Because there are some games, there will be a storyline. So as and when you go on the search and explore something, you'll be able to find something spot. I mean, something. What is it? You are able to reach the goal, something like that. So dynamically, the animated character should be generated dynamically. It should be revealed. It should be animated. So there comes the AI-driven animation. And one more thing is enhanced user interaction, like multimodal interaction. As I earlier said, not only voice, image, or something, gesture and touch, like that, you can have the multimodal way of interaction so as to have the seamless AR experiences. And of course, in wearable devices, AI is called upon to provide the context aware assistance and emotion recognition, even eye tracking, right? It has to gaze detection has to be done accordingly. In gaming and all, based on your eye tracking, some action will be taking place. And if you see the vital role of AI, of course, as I said, these are the benefits: enhanced object recognition, tracking, personalized user experiences, real-time spatial mapping and interaction, optimized performance. So whatever I said you, right? I told you so far. And some examples. Anyway, I want to show you some use cases for the convergence of AR and AI. So to be even more understandable, you could see the first one, industrial training and maintenance. So always we say AR training simulators, right? It's like, if you want to give any technician to give the training, a lot of manpower are required. Instead, if you develop this kind of scenario, it will help them to get to have some training on how to do this, right? So otherwise, we can say this kind of AR app can provide real-time diagnostics, right? If you keep your device with AR algorithm on top of this, it will say whether this has been any defect is there or not, right? Real timely it will be done, and the maintenance support it will be providing, something like that, right? And we have a AR solution called Pinnacle AR. So this is a training for the equipment operation. So if anybody wants to do this equipment, how to do this, something and all, they'll get trained with the help of Pinnacle AR training simulator. Upskill is another one. This is for machinery repair. It will keep on tell you what is a thing fault and how you can correct it, something and all, maintenance, right? That will give you. And site mission is another one. As I said, it will provide the diagnostic data whenever you show in front of the equipment. And View 6 400, no? It's also providing the real-time repair instructions. And especially in healthcare, it has got a lot of scope. For example, if the doctor is doing the surgery, no? So if he is doing the surgical this thing, on whenever he uses this kind of AR devices on that patient, it will overlay the patient data on real time, and real time value will be shown on top of that. Even the remote consultation is also possible, right? So it will overlay the critical data at the time of operation during the surgery, right? And also the remote consultation. For that only we have Microsoft HoloLens in surgery. Proximi is the one which will give the real-time guidance, right? Remote consultation. And for doctors, for surgical procedures, they want to get trained up. They have Ozo VR, through which they can visualize the anatomy of the body. They will get trained, training platform. And for visualization of the spinal surgery, right? The patient monitoring for that Augmetics is another one. So everywhere the AR will be very helpful to overlay additional information about the particular object, whatever it is. In addition to that, real-time monitoring, real-time diagnostic is also possible. And retail marketing, as I earlier said, you can have the virtual try on like this. If you focus here, how this dress will look like if I wear this dress, something like that. Even Zara, right? The Zara has Zara AR. It will give the product information. If you just show on top of some dress product, it will give the product info and recommendations also, whatever your reference preferences. And Modiface is one where you have the visual try on, right? As I said. And even for makeup, hairstyles, right? How I look like if I do this makeup. If I change my hairstyle, how I look like. So that is a Modiface. And as I have earlier mentioned, IKEA, right? That is to have the furniture visualization. And style analysis app site is there. Simply, it will suggest the product based on the user uploaded images and your preferences. It will suggest what products you can go for. And with respect to education field, of course, a lot of use cases. Here you will have the immersive and interactive learning experience, right? For example, if you have the Google Expedition, this is one AR tool available for interactive learning. So it will give the real-time feedback, right? It will provide you the educational experience. For example, see here, the students are showing this iPad in front of this. They are able to visualize the entire visual content here. It's all about universe, right? Something like that. And Kahoot is another AR solution. The thing is that suppose if there is a student using this AR app, learning something, he'll be provided with the different content, tailored content based on the performance. For example, if student is performing poor or average student or bright student, accordingly, the interactively the quiz questions will be varied, right? So that will be also provided here in Kahoot. And virtual labs for any scientific experiments, right? Science experiments can be simulated in a manner, AR manner. They simply show on top of some experiment name or experiment device. It will show you the simulated environment, and you get to know how it is all about happening. Virtual labs. And of course, gaming environment entertainment is one area where it is mandatorily the need of the R, right? AI driven AR. Here, personalized gaming experience. See here, just a Pokemon Go. So it is a normal scene in front of you. You just show it. The Pokemon animated character will be created, and you can do with hide and seek play game, something like that. You can play with it. So it combines AR and AI to create the dynamic environment that will adapt to the player action. Whatever the action you do, accordingly, it will do the action. Okay, dynamic. And of course, the live sports broadcast, right? So when there are any sports live events are there, whatever the real time, the statistics about the player or everything about the play can be overlaid. And interactive storytelling, right? So that whatever the based by the user behavior, it will give the narrative experience differently. And as I earlier mentioned, no, the navigation and location based services. So if I'm walking on the new place, right, new city I'm visiting, I don't know how to go, and I need to know the navigation. It will provide you the all those information about the place, like Google Maps. We all have Google Map already, right? The navigation instruction with voice also, and we have City Mapper, another one. So it will provide you the what is the route I can go on, take on, and what are the point of interest. It will be shown visually like this. And architectural design, right? That's very, very important. See here, in front of me, only the layout design is there. If I show my this thing device on this, I'm able to see how this construction will be. How if I build some house on based on this layout, how it will look like. Right? You all know many architectural people, architects are using this. And then that's what it's a hollow builder. You can visualize the designs in real world context. And one more thing is collaborative design. So in collaborative design, here one side the architects, the other side clients. They all can share the design and they have collaboratively they can design. Okay. So this is called SketchUp, Trimble SketchUp. So real-time collaboration on virtual models with architects and clients together. And especially in automotive industry, right? With respect to vehicle maintenance, or if you want to know is there any problem with the device, vehicle, everything is possible here. So it will provide you the real-time traffic updates also, right? Vehicle maintenance. For example, if you show on top of the car, it will give you the AR overlay, right? And it will provide you predictive maintenance information also. And there are some case studies, right? I'm having it here for you to show it. These are the success stories. Already there are very many companies have adapted AR with the AI for their successful services. For example, field service and maintenance, right? It is called Scope AR. It is a leading platform. They use it for their authoring and deploying and viewing the advanced AR content like this, right? So simply it is recognizing the parts and it is doing the real-time diagnostics on the physical equipment like this. Immediately it will say what is this part and what is the problem with this one. Everything is analyzed here. And if you see the role of the AI here, it is helpful, very helpful for the technicians. And based on the technician proficiency, it will keep changing the remarks, customizing the guidance. That is one. And forecasting the maintenance needs, right? That is called predictive maintenance. And of course, it's real time, right? Simply, if you see it on the equipment, immediately you are able to see the diagnostic information. And of course, the real time support, right? From different place, remote assistance is also possible. And training purpose, very much useful. Because if you want anybody to get trained, technicians, on how to do this maintenance or service, everything, they can make use of this one and they can get trained. And Vein in healthcare, this is very helpful for healthcare professionals. Suppose people want to give the injection and they will test it on our hand. Very difficult to get the vein, right? So this is a one vein finder, right? It uses AI technology to find the patient's vein when you're checking it for the IV start, right? See this, they could see the view of the veins. So directly they can see the veins here and they can put the injection or any procedure they want to do, any trips, something like that. So here the vein detection, you making use of the image analysis, right? This is the role of AI here, and personalized visualization. So it adapts a projection based on the individual patient characteristics, right? Everybody will be having a different way of their vein characteristics, right? So accordingly it will do. And IKEA, as I have earlier mentioned, like this, if you want to purchase some furniture for your house, how it will look like, you can visualize. So in what way I can place this furniture, something like that, right? So it's a previewing the furniture in your home before making a purchase. This is just to know the virtual placement. And of course, here it has the AI role in the context of personalized recommendation, right? It is like based on your preference and need. If you take a picture of your room, accordingly it will suggest, show differently. If it is somebody else's room, it will be differently shown. So it is a personalized recommendation, and it has to understand the scene, right, in front of the environment. So there also comes the need for AI, all those things. And Pokemon Go, as I earlier said, right? So just to enhance the gaming experience. So virtual creatures, Pokemon, will be dynamically created, it will be added in front of you. And whatever the way you keep your device, right? The position, even if you are running and you are walking, accordingly, it will position yourself and it will give the overlay. Superimpose the animated Pokemon on the live camera feed like this. And so here dynamic game environment. Suppose if we move from this road to next road and some tree, when there are some park I'm visiting or I'm going to some other place. So different environment or to be dynamically keep changing, it has to understand. So there comes the role of AI, dynamic game environment. And of course, character behavior, right? And user engagement. All those things are involved. And Google Map, we all know, right? So location-based services. So it is a live view you can have. So it is overlaying the directional information onto the whatever you have your camera in front of you. It will overlay the information, and it makes use of the camera inside your system. The ultimate challenge is here identifying the real-time objects in front of the road, right? What are the street signs or any landmarks it has to identify, and it has to provide the optimal route, quickest path, right? All those things are there. And this is another one for manufacturing and design. PTC Euphoria and Creo is a solution. Uh, as I earlier said, it will optimize the manufacturing process and predictive maintenance, right? So it will simply analyze the design data and it will suggest what way we can design the product, right? Optimally or efficiently. So it is a design optimization angle. AI scope is there. And of course, overlaying the 3D model, right? How the manufacturing, that the design will be like this. I need not design physically and finding that it's not good and I have to go back and redesign. Instead, I can visualize if I do this kind of practices, how the designed product will be, right? Like that, I can visualize before in hand. And also for predictive maintenance. And snapshot, all of us are very familiar with snapshot, right? So this is called Snap AR. And here, it is simply using the personalized AR experience. And this is for what to say, like it is very well used for the digital marketing campaign, right? So the appropriate brands will create the personalized AR experiences for the users. Of course, it has to recognize your face. Accordingly, it will apply the filter. You can see your face in a different this thing, right? I think I have visuals in the next few slides. So this is a way the snapshot is also making use of that AR and AI. And the content will be personalized actually. So based on the person face is captured, according to the face, it will provide the tailored AR experience. And again, at the IKEA retail, with respect to that retail scenario, I have simply mentioned the role of AI here, computer vision and 3D model rendering with AI, scene understanding with the deep learning. So these are the place AI role is there with respect to the IKEA AR app, providing the 3D models of the furniture in the captured visuals of the environment. And another one is Sephora virtual artist. It is like a makeup try, right? Virtually, we can say how I will look like if I adapt this makeup. For that, it has to understand your face, recognize your face, and it has to track the facial features also. This is like a real-time makeup, right? Application. So virtual try on. And when you do the virtual try on, it makes use of generative AI, that is a GAN network, to generate your new makeup applied faces with all those textures and colors properly generated like that, right? It is like visual try on. And even for clothing also it is possible, right? If I try a different accessory, if I try different clothes, how I look like, the fabric is to be simulated also. For the deep learning is used, right? Simulate the fabric behavior for realistic appearances. And the product visualization, as I said, the furniture and how the interior of my home will be look like this. And interactive product demos, right? That is also there. So it will enhance the shopping experience of the user. And education, as I have earlier mentioned, it is especially for the students to explore the 3D models better. For example, historical sites or human anatomy, they want to have an understanding in a good manner, right? So they can have. And the HP reveal is the one. The teachers can create the interactive lessons with AR, right? Suppose if you have the textbook content or posters, on top of that, If you want to come up with some very quite interesting 3D models, for example, like this, see here, some normal static images there. About that, the particular animal 3D model is created. It will keep moving. It will do all necessary actions. And the information about that is also can be popped out like this. So of course, machine learning is required. Computer vision is required. The GAN network is called upon, generative AI, to simulating this. Even for any historical events is to be simulated, right? And you can interact with this one also, right? As I earlier said, you can give your voice, you can type down to interact. So it has to understand. Of course, NLP is used, natural language processing. And even virtual field trip, right? It is like instead of taking your children to some place physically, we can have the virtual field trip, right? So they can enjoy the particular place, can be simulated, and they can realize the life. And as I earlier said, textbook can be enhanced with the 3D models. And the virtual field trip scenario, any historical site or even museum or any place you want to take them, even across the world or any country, that can be simulated in a virtual way in an immersive environment, you can provide them. Along with that, voice commands, everything possible. As I said, the healthcare, already I have talked about this AccuVein, right? Just to project over the skin to know the vein position so that the injection can be done. That is one. Another one is hollow anatomy. See here, this is one hollow anatomy, just to study the human anatomy in 3D without the need for the cadavers, right? So always, getting the cadavers, everything is very challenging, difficult field, right, for the doctors. So for many training to the students, this is very easier task. So here, very realistic 3D models will be given to the students for visual representation of the body. So they can also interact. They want to see the specific things in more focus. They can understand better also. And surgical planning, as I said earlier. So whenever the surgery is happening on the fly, the doctors will get to know about the patient's data. And if they want to see the CT scan, right, or any MRI scan, and on top of it, they want to know the information about the scan details very immediately, they can make use of it, right? All those things are possible. And medical training, as I earlier mentioned, right? Virtual simulation of the surgery and anatomy. And even the reinforcement learning is used for interactive simulation. For example, this is called virtual surgery simulation. The students, if they ask something new, accordingly, it has to immediately develop the different view of the anatomy, and it has to present it in a virtual manner. So for that, reinforcement learning can be used. And as I said, any interaction, your real-time explanation, right? You are asking questions, it has to answer it has to answer for the questions related to medical structures. Then NLP can be used, and visualization, all those things, speech recognition. And manufacturing industry, as I said earlier, for example, Boeing AR, right? It is like aircraft wiring assembly. If you want them technician to get trained, so it's very costly, very expensive training. Instead, if it is virtualized like this, so immediately they can get trained. And as I earlier said, PTC Euphoria. This is for manufacturers to create the maintenance guide or work instruction or training modules, so that the technicians can get to have some idea about it, how they have to do the training, get to have the training, or how to do the maintenance, and all those things. The step-by-step guidance will be given. So simply they have to show this developed app, AR app on the particular equipment they want to learn. It will provide the virtualized simulation of that. It will give the explanation about it also in the voice overlay. Same thing is given here. The worker training, the maintenance and repair assistance, step-by-step AR instruction, and process optimization, right? So the real-time assembly guidance. If you want to do the real-time assembly or aircraft, something like that, it will help you how I can do it step by step. And real estate, that is even more very interesting area where it has got its role, AI with AR. For example, see here, this is our normal place. See this, it's like a forest. Here, if I show this one, if I have built some house or something like that, building here, how it will look like. Here, if I build one bridge or this way, if I convert this into a very smart city, how it will look like. So something like that I can plan, right? So that is the one. And with respect to real estate, we have a solution called Matterport. It will create the 3D virtual tour of the real estate properties. So that you can attract the potential customers. So it can be played back. They can enjoy the virtual tour of being in that place. They'll come to know how this will be, right? The room dimensions, everything they can realize and feel. So over that, they can have the virtual assistants answering also. Rather than visiting the real estate place and seeing the virtual in the real property, they can have the virtual property tours. And Orki is another one. It is an AR app useful for the architects and real estate developers to visualize this building designs like this in real world environments before it is being built, how it will be. So it will really actually building the 3D models. It is available for interaction also. Same thing is repeated here. Virtual property tour, it will allow the buyers to explore the homes and buildings remotely rather than visiting the place directly. And visualization of the architectural designs and home renovations like this, they can do. And enhanced marketing materials with AR-enabled brochures and flyers. For example, if you have a very standard marketing materials, right, normal brochures and flyers, it may not be very attractive to the customers. So if you have the AR facility added, simply having got a brochure, if you keep your device on top of it, you can, it is a marker-based scenario. So it will get to have the brochure content. It will develop something, the marketing, whatever the quite interesting content will be developed as a digital overlay. It can project on top of it. So it is called interactive marketing. And as I earlier said, entertainment and gaming. So the Pokemon game I already shown you. See this, this is the AR music experience. For example, it is a live experience. One person is a musical show wherein he's doing a live performance. In addition to him, we can have the avatar overlay like this, right? Very quite interesting avatars can be created virtually. It can be overlaid on this screen where he's projected, this one. So that it's very more engaging, right? So here it will analyze our audience behavior. Accordingly, it will change the visual effects. It will keep on changing the visual effects so that more engagement will be there for the audience. On non-playable character behavior, as I said, a very intelligent, dynamic behaviors with characters can be created on the fly. And everywhere, as I said, dynamic story progression, everything, it is like a interactive storytelling you want to have on top of any book. AR enabled books, comics, right? As and when I go through the book, if the user wants the story to be differently told, I can give some input. Immediately, it will dynamically change the content. AR content, it will provide back. So that is also possible. So AI powered narrative generation. So even I can change the storyline, right? Something, the plot can be changed. So it will dynamically, it will change the AR content and provide on top of the book. And tourism and navigation, as I earlier said, right? So walking direction, generally Google Map, it will provide the overlay like this, right? City guide apps. So new places I'm visiting to explore the city, all the overlaid information about the particular landmark, everything, it will show what are the restaurants nearby and which places I can visit. So all necessary attractions will be available for me as overlaid information very quickly. So rather than going and searching everything individually, if I simply show my phone over some place, it will suggest me all the recommendations. What places I can visit, this place is at what distance from my place, what are all the close by restaurants I can visit. So like that, everything visually shown to me. Same thing is given here. And the historical reconstruction, as I have earlier said. So for example, current location, it would have been developed over the past or 50, 60 years. But how it was before 50 years, if you want to see, that is also possible, right? So overlaying the historical images onto the current view, right? So that is also possible. And especially in automotive scenario, BMW car, they have their manual itself, owner manual itself as a AR. So simply they can point their smartphone only on the car. It will say information about various things, about the car features. It's a manual, right? So generally, if any manual you are given with, you have to read and you have to understand about the car functions, everything. Instead, simply point out on the car dashboard or windshield, immediately it will provide all necessary information. Like that, Audi car also, they have the virtual cockpit. So they have the dashboard that overlay the navigation and driving information dynamically. When you are driving, you could see the navigation and driving information in front of you, right? That is again the overlaying information. And with respect to military and defense, so this is called AR training system. This is a very, very important sector where it requires this AR. Actually, all soldiers are to be get trained on a different controlled environment, right? So dynamic combat scenarios can be simulated so that they'll get trained. So real time, we cannot make them to go to a different scenarios and get trained. So instead, here it can be virtualized so they can get to have the more experience. And also, they can also get to interact with this system, virtual environment like this. And even if you know the kind of fire engine department, right? If the trainers, if the whoever is the fire engine safety officers, they want to get trained every time, we cannot make them to go to the place where the fire is there, right? Instead, the fire can be simulated and they can get into the environment. They will feel, they'll have the feeling. If really, if there's a fire in front of me, how I have to deal with. So all those things. Even AR headsets are there for soldiers, right? So dynamically, it will show them what is the enemy position, what is the mission objective, and where I have to go now. If there are any commanders, next level commanders are giving the commands, immediately it will be flash so that they can keep moving with their actions, right? So all those things. That is called combat training simulation, right? Very immersively, they can get to how the training scenario. And one more thing is that if the enemy is behaving differently, how he has to change his strategy. So the adapting the strategy based on the soldier action, even the simulating the enemy behavior, right? That and all possible here. That and all not possible. No, for every soldier, we cannot give them a different battlefield scenario. We cannot expect them to get trained differently. So with this, everything is possible. And marketing, as I said, snapshot. So here, filters you could see. It will simply take you a picture. It will show you different filters on top of your face. It will show overlay this information like this. So it will change. Of course, here computer vision is required for face recognition and the machine learning for filter optimization. And Pepsi, see this one? It's a normal bus stand, right? Bus stop. The people are waiting. So here it's overlaying the information where bus stop commuters can saw some tiger or aliens are overlaid here and the real street design in street this scene. It is like attracting the people. It's like a marketing advertisement for the Pepsi. They have like this. And if you see the applications, as I earlier mentioned, of course, it has got lot of domains, right? Healthcare, it has a scope. retail, education, manufacturing, this thing. But everywhere there are some features, challenges are there. Of course, the computational power is very much required, right? And privacy and security is a problem here. Ethical consideration is also the issue, challenges. So when you see one side, there are some benefits like your experience will be more enhanced, right? Improved accuracy, everything is there. But there are some concerns when you are adapting AI with AI. Of course, data security and privacy and ethical concern usage is there. And the user trust is also very important. So if you see the future of this AI in AR integration, there are very many advanced AI capabilities can be done with respect to the very precise object recognition, improved spatial mapping, better virtual physical interactions, right? And ethical frameworks also can be better enhanced by regulation with better regulations and industry integration into more sectors with more enhanced experience of the customers and by involving more technological evolution, right? More make it more accessible for everyone and collaborative ecosystem. Like you can make it to how the collaboration among the technological companies and researchers and policymakers so that we can have the interoperable solutions. So these are the features, future of the AI with the AR. And these are very many AR tools, simply for your reference. We have Unity with AR Foundation, Unreal Engine, Muphoria, AR Kit, AR Core. And with respect to 3D modeling animation, we have Blender, Maya, 3D Max, and SDK, Wikitude, ECAR, Zappar, and content creation tools I have listed here, Lens Studio, Adobe Arrow, and prototyping, right? For that also you have separate tools. And to make it as a web AR, I have talked many times about mobile AR, can also be rendered as a web AR platform. For that we have A-Frame and 8th Wall. And these are the required hardwares, right? HoloLens, AR glasses, and Magic Leap. So these are the necessary facilities required to enjoy your AR experiences with AI integration. And as I said, there are some challenges, right? Technical limitations and user experience, privacy, and content creation. You know, if you want to develop it for a new sector, you have to have a very high quality AR content, right? That requires a lot of specialized skills and tools, without which we cannot develop a AR overlay. That's a big challenge. And as I said, these are the future scope advancement with respect to the hardware and more AI integration with respect to the more intelligent interactions can be done, providing the more contextual information, more use cases spanning across even mental health therapies. For that also we can make use of this. And interoperability, as I say, it's earlier said, requiring the standardization and collaboration across the industry so as to have the interoperable solutions. Thank you. I think I have exceeded time. Any questions?
Thank you, madam. Any questions? Participants? Ma'am, I think there is a chat box. Question is.
1 second. You could not say any questions.
Madam, I have one question, ma'am.
Virtual cockpit or dashboards available to mark. Is that one? 1 second. I guess AR and automobile still developing under concept models or cars. Yeah, virtual cockpit dashboards are available. Just now I have shown you one use case. In Audi car and BMW, they have that. It's only dashboard available for just to know the navigation directions and other stuff. And even for aircraft and all, they have the virtual cockpits. And for training simulator, under the training simulator, for the pilots to get trained. All those things are there.
Ma'am, I have one question.
Yes.
Ma'am, this AR/VR systems often capture this spatial or biometric or our behavioral data or
Yeah.
responsive data. What are the regulatory compliance in
That's what.
place so that it should not be misused?
Yeah, that is a big challenge. Still, no, there are some guidelines like whenever they capture your thing, they say that it will not be misused for any other purposes, something like that. They have already guidelines. Once you are accepting, agreeing, only you are allowed to do that. They'll be taking your information to go forward. So if you are accepting, then it's okay. But generally, there are some strict guidelines not to misuse this for any other purposes.
But how do we find out, madam, whether it is misused or not? You see, our mobile numbers data, TRI has got so many regulatory authority giving out so many policies and for this data privacy preservation and all. But still, it is gone to marketing people hands.
Yeah,
Where do
that's
we
what.
check and how do we check this?
Yeah, that's what I have shown you as a challenge. No, the last slide I included. Still, even though they have the strict guidelines, there are some misuse of those things are there. The government is coming up with a strict guidelines for that. It's under payment only, but anyway, these are the things under focus actually. But there are some solutions which are generally, the private sectors. For example, if the particular company wants to give training for their own employees, right? They have developed their own AR app. For that, they make use of their authenticated, whatever the biometrics, this thing they capture. They keep it very private. It's not the standardized, the public solution they allow them to use it. But there are some public, even we have Google AR and all is there. So where it is capturing your face, everything. But there are some guidelines they have strictly followed. But still, it is one of the challenges.
Thank you, ma'am.
Thank you, madam. Any questions? Participants, any questions? I think no questions. Thank you, madam.
Thank you, ma'am. Thank you.
Thank you for sparing us with this much of information. We were all of us immersed in this AR and VR, and thank you for your sharing the knowledge. Thank you so
Thank you.
much, ma'am.
Thank
Thank
you.
you so much.